This session, we're gonna talk about the Blob transfer project, and at the beginning, that why we have this project is the Kafka ingestion in our current use case will result that for the deployment and also node recovery, the time takes too long. So we are thinking about a new solution, which is directly do a peer-to-peer data transfer. And the data used in the transfer is a RocksDB snapshot. It can ensure a point-in-time data copy. And we also consider that the use case, if the Blob transfer is failed or is success, no matter what, it will fall back to the Kafka ingestion to either recover or fill the gap between the RocksDB offset record or to the latest offset. And it's relatively lower risk, especially in DaVinci use case. The reason is the DaVinci use case is relatively simple compared with the Venus server. For our DaVinci client, once their deployment is done and the client host is ready to serve, then it means that the bootstrap is successful. Either it use Blob transfer or fall back to Kafka ingestion. It means that the host is ready, RocksDB is ready. So let's move to the overall data structure. Firstly, the client node, which is the node that needs data, it will send a request to get the host list information. For Venus server, it will query Helix to get the replica information. For our DaVinci client, it will send a query to get the push job report. And then it's gonna return a list of a host list. Then this client node will send the request one by one to first host. If the first host do not have data, then it will reject this request. And then the client node send the request to the next node. Maybe at that time the data format is not matched, and then it also will reject. Then the client node try to connect the third node. At that time, the server say is not busy and do a like simple check about the table format. If the format is matched, then the transfer is starting. And first, the server will send out a file. SST file, file 1, file 2, and send the manifest file. After all the file is sent out, server C will send a metadata. This metadata contains the offset record and SVS. The SVS is mainly for the hybrid store use case. And then server C will send out a complete flag to indicate that for the server C, everything is sent out. It won't do any action further. After the client receive all the file, client will, and it will notice the complete flag. Then the client will do the validation and the next step. It will first compare the file checksum with the response header to make sure the checksum file length is matched. After this is passed, it will rename the folder because all the files sent at this step, this file is stored at the store name partition with a temp prefix. After this is success, it will rename this temp folder to a partition folder. Then it will later open it as a RocksDB format. So because all the file is RocksDB file sent it out here. And after the partition folder rename is successful, it will fall back to Kafka ingestion to fill the gap. Because the snapshot has an offset record, May is not fresh enough. Then it fall back to Kafka to fill the gap between the snapshot offset to the latest offset. And this several step is the detail. And then we can move to the detail about the client side, how the client side processed during the entire step. In the client side, it will first do the peer discovered. For Venus server, it will query the Helix, the customized the Helix CV to find the node in complete status and filter out with store version partition to get a list of store. For DaVinci application, it will curate DaVinci push job report and file ready to serve node and extract available peer lists. However, sometimes for Venice server, the use case is easy because the return host is like just their replica. But for our DaVinci client, the use case is kind of complicated because during the rollout, one of our clients, they return 200 node, but or 2000 node. But within their 2000 node, there is only 5 node is enable this feature. Result that if we send a request to this 2000 nodes one by one, it's very time consuming and then the thread is hung. So we add one more step in here to check the return list connectivity to ensure that those return list host is connectable. It just use a hash map to store all the hosts that is connectable. So if we move to the next partition, it will just refer this hash map. No need to try the connectivity again to saving the time. And then it will start the data request. It will first send the HTTP GET request and get a response. The response header will contain this file name, like 001.sst, and then later receive the HTTP content. This content will be a file chunks. After all the file is received, it will start receive metadata and start receive a complete flag. After all this step is done, it will start validate the file checksum and rename the folder. However, during all this step in here, any stage error could happen. So if when we send the HTTP request, there still could be an error that the connectivity is a connectivity exception. The reason that might happen is even in the first stage, we get a host list. For example, we get Venus server replica host information. But the next minute, it start serving the request. That host itself goes to deployment, start its own deployment, and then this host is no longer connectable at all. So even at the first stage, the connectivity error could happen. But at that time, nothing really send it out. So what we need to do is just move to next peer. And another possible error is it sent out a request, but that replica just drop that partition, so it don't contain this partition at all. So when the sender node received the request, it found that they don't have this partition at that time. Then it also just request with 404 error. And another kind of error is the sender node is busy. Why it could be busy is the sender node. At that time, it send out file. It also will serving the reading traffic, but we don't want the sender node to overwhelm me. So we have a configurable number. This number gonna control how many concurrent requests the sender node will serve. If the serving amount is existed that config, then all the later requests are gonna be rejected until the server node complete one config, and then this number gonna go down and continue serving more requests. So at that time, at that stage, also not any file is real sent out. So what the receiver node do is also try to connect to next peer. And the very tricky error is the transfer error. The file is already start transfer, but there is some error. This also happened while the sender node is sending out file, but the next minute, the sender node start its own deployment, or just this sender node is shut down. The entire connectivity is break. So the file is the file is not even fully sent it out. At that time, what we do is we clean up the file and we clean up the entire partition folder and move to next host. After all the file is sent it out, it will do the metadata gonna send and fall back to Kafka ingestion. And then let's see what the server side do. That's large enough. Yeah. For the sender side, when it receives the request, it will check the store name, version number, partition number, and the table format. This table format could be plain table or rock-based table. The reason we have this is sometimes if the French client one of their hosts use plain table and another host they use rock-based table, and at that if we don't know that their format is match, then we just take a snapshot and send out RocksDB with the wrong table format. And also the server will check if this is out of their global limit. If the concurrent saved request is too much, exists the concurrent save request, then it's gonna reject the request with 429 error. After it received this request, it starts preparing the snapshot it plans to send it out. Because we don't want the sender node, every time it received a request, it generated a new snapshot. We don't want to do that. So we have a mechanism to maintain the snapshot freshness. This freshness number is also configurable. So if the first request arrives, but the sender node don't have a snapshot, it will generate a new snapshot. But if the second request arrived, it will check that this snapshot's freshness. If this is within the freshness amount, then the sender node won't recreate a snapshot, but use the old snapshot within the freshness. And also it will prepare the metadata. This metadata is contains the offset record and the SVS. This SVS is more for the hybrid store configurations. And the metadata gonna be the JSON format. And then we start.
Question. Okay, what's a snapshot means?
The snapshot is a RocksDB at that time. Okay, I have.
So we have the table and the snapshot. What's the difference?
Let me do this. Yeah, because I don't plan to talk about snapshot, but because then it will contain too much information. But since we have question here, so we talk about what is RocksDB snapshot. RocksDB snapshot is a point of view of that database. So it means that at that time, when we get it, just get a sequence number of this RocksDB and create a hash link to SST file and maintain this consistent view and all later data for that RocksDB. Because that sequence number gonna less than the sequence number when we take that snapshot. So when we have this snapshot, all the later data we won't contain in the snapshot.
Jingyan, quick question. So log compression will not clean up the SST file that being linked.
Sorry, can you repeat your question?
Yeah, sorry, not log compaction. So when RocksDB do compaction, like the SST files that are being linked by the snapshot, like they won't be cleaned up.
Personally, yes, it won't be cleaned up because it is stored in a separated folder called snapshot directory. And the second is the first is compression won't clean up the snapshot, and the second is the snapshot cleanup is done by a separated thread, do a periodically snapshot cleanup.
I see. Yeah, thank you.
Is there any further questions?
I'm good.
Oh, sorry, just a quick question. I didn't find this part on the PR that you shared.
Yeah, in the PR, I commented out because I'm not sure I want to contain this in the doc, but you can search in the RocksDB magic this word and in the raw MD file, so it will show up.
Oh, okay.
In the MD file, you not view it as a file format, but in the raw code, so it will show up this context.
Oh, I see.
I have a
Yeah.
question. How is the chunk size related to the partition? How many chunks do you get from partition?
The chunk size is we just want so close to talk about chunk.
Oh, okay.
Station
So
and
we
talk
talk
about
then,
the
yeah.
chunk. Yeah. So then we talk about how the server send out a file. So I put the single file transfer process in here. Is for the server side, how it chunking, and for the client side, how it deal with when per chunk is received. So please note that this is for one single file send process. So now the server start prepare the file in the read-only mode and calculate the file length and the file checksum and put it in the HTTP header because this number gonna be used in the later validation. So we put it in the header for now. And then we use a chunking strategy. For now, every single file will be divided to chunk based, the chunk size is in this range based on the file size. And then it will create a chunked file handler and the streaming to HTTP and the wrap to HTTP stream to send it out. And use the channel write and the flash to send it out. After the file is sent it out, it only log some file send out message and complete this file send out complete this file and ready for next file send out. And for the client side, what it will do first, it will get the HTTP handler. This handle will contain file name like 001.sst and the file size and the head and the checksum. It will store in memory for the later compare. And then it will create an empty directory. The path is store temp p0. And then there is a question is the first file arrive, then it will create a temp directory. But when the second file arrive, then it will skip this temp directory creation because it will directly use the existed directory. And then it will create a temp file like because we know the file name here. So it will create a temp file like 001.sst. And then now the header part is received. Then it received the HTTP content. This HTTP content gonna be in chunked. The first is the raw network package, but the native will convert it to the byte buffer. And because we want to write it in file, so we use JavaString to convert it to buffer byte input stream. And for write it down, we then convert it to a readable byte channel, and then use the file channel to really write it in the file we created in here, in this empty file. So all the chunk is repeating this step until the last chunk is received. Native will indicate that this is the last chunk of that single file. At that time, the client will do is force the data to disk and close this file channel. So this file channel is the step that really write the data from the channel to the file. So it will close this file channel. And then it will submit a checksum check in the backend because we don't need to wait the checksum result at that time. So we just submit a checksum check and clean up all the like the file name, reset the file name to none, file size to none, checksum value to none, to make it ready to receiving the next file. So this is how one single file send it out and receive. And then we move to the metadata transfer. And I want to call out is that the order is very critical here. We must send out the file first and then send the metadata. The reason is first, the file is more easy to break compared with metadata send, because metadata is sent once, one time, it's done. And but for the file, it's gonna be the send time gonna be number of file times number of chunk. So file transfer is more easy to break. So if we send the metadata first, if the later stage, the file is break, then we have to revert the metadata. But what if the revert stage is also failed? The metadata, once it's received, it's gonna sync the offset to the receiver local memory. So the receiver will sort that at that time this RocksDB offset is, for example, 2000. But if this revert stage is failed, everything failed, we revert the metadata. But this is also failed. Then it fall back to Kafka. Kafka start ingestion. But at that time, Kafka will ingest the star from the 2000 plus. Then the data in the range between the beginning and the 2000, they are silently break. We never know if this is really in there. So it's gonna silently break. But if we use this order, the file is break. We just clean up the folder, it's okay. And we send the metadata. If the metadata send is fail, we're gonna revert all these two steps, right? If the metadata is not sent it out, we only need to clean up the file. If the file is not clean up, it's okay, because when it fall back to Kafka ingestion, it use this folder. The Kafka is use the real partition folder, but the file we send it out is in the temp folder. So even this folder cleanup is failed due to some reason, it won't affect how the Kafka do recover for this. So this is why we have to do in this order.
Question.
Okay.
What happen if I don't send the metadata at all?
Then this is also gonna handle this. What if we have the file, this RocksDB already contains the data, like up to date, very fresh, and then the metadata is sent at all. And then it thought, okay, I'm complete and move to Kafka ingestion. But when it moved to the Kafka ingestion, it's gonna start from the beginning. So it's gonna ingest from the first record, and despite the RocksDB already has all the information. The worst case is just take more time to do the ingestion again, but it won't hurt the data anything. But if in this stage, some data might missing, but we don't know.
So basically, we'd rather do it from scratch than do it wrong.
Yeah, it's basically, it means we would rather take more time to let it from the beginning rather than some data is missing silently. Yeah. And also we have the global shaper, which is a native built-in method, is a global traffic shaper handler. This handler gonna control this, also configurable to control all the channels reading and writing speed. So this is per host level config. For example, if the sender node, they are saving the reading traffic, so we don't want it overwhelming. Then we can set the config that use a less writing rate, then the send it out step won't affect a lot for the sender node to serving the reading traffic. So, and also we adoptive throttling method on this NITI. So even if this method is configurable, but it can dynamically adjust the rate based on the current traffic. So and then this is a snapshot.
When you say like current traffic, like what traffic?
For example, our Venus server, when the server is ready, it gonna serve the user traffic, right?
Okay.
User sends the reading traffic, we send it back. But at that time, if the server is serving our outside client request, but at the meantime, it also send out file for the Bob transfer, then it might compete with each other. So we don't want this feature to affecting the reading traffic from the outside from our client.
Also, quick question on the rate limit is on the, so the quota is based on the channel. Like channel is like a thread sending the files.
This is based on the channel, but we need to notice is the value is controlled by the combine of all channel. So for example, because this channel is per partition gonna have a channel. So this config, this global shepherd is control for all channel. It's the sum of all channel.
Oh, okay.
And this is and then talk about the snapshot. We maintain the RocksDB snapshot manually. When the request is, we have a thread to periodically clean up the snapshot and to maintain the disk storage. Yeah, and
So like we implement that cleanup.
Yeah.
Okay.
And this is the config. We have two sides of config. One is the receiver side, and one is the sender side. For the receiver side, our Venus for our Venus server, it can control by both the store level or host level. But for our DaVinci client use case, it's only controlled by a store level. And for the sender side, because the sender has less bad effect, so it is applied in host level. And there are some features is tunable. One is offset lag. At the beginning of Bob transfer, it will check the current offset. If it's not lagging enough, then it's no need to do the Bob transfer. It can just directly do the Kafka ingestion to fill the gap. And also there is a snapshot freshness and how frequently we do the snapshot cleanup. And have the client side read and the server side write speed control through NITI global shepherd handler, and has adaptive range to dynamically change the speed. And the concurrent snapshot user, it means that how many concurrent requests we can serve for the sender node. And also have timeout, because there might have some error we don't know. So if the sender node send a file too slow, or it's just the thread is hung. But we don't want to endless waiting forever. So both the sender side and the receiver side has a timeout to control to avoid that the file is underneath the waiting or underneath the sending. And this is basically about the Bob transfer project.
I have a question. Like when we say sender, the config part, we have like a little bit of, yes. So I see the receiver, we have Venice server and DaVinci. Like, but the sender, all application, what are all applications here?
Oh, the all application means Venus server or DaVinci client. Both of these two,
Oh,
the config is controlled by this application config. layer level config. This is the host level.
So it has to be coming from Venice ecosystem applications.
Yeah, for our Venus server, it's enabled in backend, but for our client, they just enable in there.
Okay.
Yeah. Any questions?
I probably have a question regarding the file transfer part. You mentioned that you will break the single file into multiple chunks
Yeah.
and send them. Why we are doing the chunking? I don't get the intuition why we do that. Why we can't just transfer the file as a whole?
Honestly, when I joined this project, the code is written in this way.
Oh, okay. It's precondition. Okay, gotcha.
Yeah.
So I think it would automatically chunk for the SSL reason. They would be wrapped into a 16 kilobyte of the TLS record under the hood. So you would like on the receiver end, you will see each chunk received as a 16 kilobyte regardless. And because we cannot disable SSL, so we cannot use zero copy or any other like more performant technique here.
You mean SSL is pre-chunking? Like, does that mean it's like we enable SSL, it's just the chunking the file into the 16 kilobytes?
No, I mean SSL is the requirement. But that the side effect is it will cut the file into the 16 kilobyte automatically.
Automatic, but this also mentioned is the chunking size is ranges 16 kilobytes to 2 megabytes.
I think that doesn't really matter. Under the SSL layer, it will still be split into the 16 kilobyte. I think I also did some
Chunking, right?
Yeah, I mean, I also did some logging when I was testing. So when on the receiver end, I do see each chunk coming in as a 16 kilobyte, regardless of what kind of the chunk size we set in the upper layer.
Are you seeing this is handled, like the chunking is handled by not us, by the underlying system? So we don't build something on top of the existing chunking?
No, the chunking calculation is handled by our side, but what Johnny means is under the SSL layer, it will chunking as a fixed megabyte, no matter what chunking size we did.
So we potentially have a 2 level of chunking.
Yeah. Yes.
Oh, okay, gotcha.
So if we have chunking in the SSL, like why do we need to do chunking ourselves?
I think is at the beginning, the chunking size is a fixed number, very small. So, but the performance is not good. So we are thinking that if using a large chunk, will it decrease the I/O operation to having performance improvement? So we use dynamic chunking here to. At that time, we want to say that if ranging of chunking based on the size, if can have better performance, so we use dynamic chunking it there.
Like yeah, so the dynamic chunking is listed there, but Jolin is saying like when it gets to the SSL layer, it's still going to be 16 kilobytes. So won't the chunking kind of be irrelevant?
So I think it may be, this is my current guessing, is like this chunk does not really affect the overall transfer speed performance because of the chunk we mentioned, but it can reduce the memory usage in the sender layer. Because if you don't do a chunking at all, you read the whole file into the memory, that's like 256 megabyte.
Okay, that makes sense.
Johnny, quick question. Are we using HTTP 1?
Yeah,
Or
1.1
2?
for now. So I think there's something we can improve. It's like for example, HTTP 2 usage, and then also the other diff solution. But all this because we don't have a protocol as we specify in other system. So it'll be a little bit harder to evolve. We may need to have a protocol between the client and the server, I mean sender receiver first, before we can evaluate any protocol evolution. Otherwise, it won't be compatible.
Oh, just curious, like other apps, you mean the other DaVinci app?
No,
Like
no,
the
no. Other, like we have all the Avro protocol in different part of our system. But for this like blob transfer, I don't think we have a good the version metadata protocol. So you cannot just like, I don't think you can just enable on one side, on the client side or on the server side, right?
Oh, yeah, maybe we can discuss that offline.
Sure.
I'm still missing. I think I'm still missing something.
Yeah.
What are some events that could interrupt the transfer?
Yeah, if in here in the arrow handler part.
I have one more question for chunking. Like,
Cycle back to it. Yeah. And if during the transfer the connection is break, if the break is graceful shutdown, then when the sender node is graceful shutdown, it will send a signal that the channel is closed. Then the receiver side will know this is a graceful shutdown, channel gonna break. Then it will do the cleanup, move to next host. However, if this is unexpected shutdown, like someone killed that host suddenly, at that time, we have a idle detect, idle like 5 minutes or 5 seconds. Once it's after 5 seconds, it not receive anything, then the idle event will trigger, and idle event will trigger exception, and then the receiver node will close the channel and move to next. So there are two kind of cases that we are handling this event. Let's back to chunking part.
just one more question, like how the for example, if file like chunk into the multiple size, that chunking task doing parallelly or one by one?
One by one. Yeah,
One by one. Oh, previously I thought like we do chunking because we want to like do parallelly to increase the efficiency.
Oh, they are sequentially.
Sequentially. Why we couldn't do it in parallel, like those tasks?
For the chunking part is sequentially, and we haven't. That should be a future improvement. Yeah, that can for the chunking part. It can be a future improvement.
Sure.
Oh, I think within the same file, it has to be done sequentially, right? But across different files, maybe we can do in parallel. But just a quick follow-up, like let's say if we have 10 files on the sender side, will it end up with also 10 files in the receiver side? And do we open like one channel per file, or are we reusing the channel? Just curious.
Yeah. This is using a same channel, so you can see all this in one channel. And the file one you send, these are sequentially send. And why we have to send it sequential is because they are one channel, right? They are in one channel. And then when the one file is received, they put the file name chunk size in memory. So if they are parallelly send out file in one channel, and then this file gonna mess up at all. So they have to send out one file, and the header contains the file information, file name, this information, and write it down, and then reset this local variable to and waiting for next file. So this is why if we are using one channel, then all the files sent have to be sequenced in our current implementation.
So Ming's question is different, right?
Oh, no, that answers my question. Yeah. So we're
that's
reusing
all.
the channel. Yeah.
Yeah.
That's right.
And this is per partition will have one channel.
So I have a question about the the source of peer. Like my understanding is currently the peer are discovered within the fabric, right? Through healers, I guess. Is it possible, like let's say in future, we can discover from another fabric too? We don't have this need now, but I'm curious if the current framework can be extended to also transfer from a different fabric.
So we want to do cross-colo transfer.
Then you need to query you need to have the ZK information from another column. I mean, it's doable, but I think the performance won't be that great compared to the in colo transfer.
Right, definitely. But if we compare with Kafka ingestion, maybe we will need to see, like we need to test and find out.
Need some evaluation.
So yeah, so currently it's through a healers API call, right, to discover the peer
From our router.
from router.
Yeah. For our router. Yeah. For Banhei. Is there any further questions?
Yeah, so actually one more question about the throttling. The throttling will only happen for the block transfer channel, right? Let's say we breach the overall quota and even never throttle the read pass channel. Is that the case?
Yeah, it's only control the Bob transfer channel.
I see. And how are we, like, how do we get the quota number? Like how
We
do we
have to
define them?
tuning this. We have to tuning this config.
I see.
So that's why I think adaptive throttling is important. We will set an initial number, just as like ingestion pool, and then we will base on the signal of the. I think currently we still look at the read latency, overall read latency, just like ingestion, and also the current version heartbeat, and then we throttling based on that.
Yeah, that's a good idea. Last question about the monitoring. So for the Kafka path, right, we have lots of metrics about throughput, things like that. Do we have the same kind of like same set of metrics for block transfer?
For Bob transfer, we have a number of successful partition and the number of failed partition and the transfer time and the transfer throughput. These four metrics.
Awesome, yeah, that's great. And we can do a side-by-side comparison between block transfer and Kafka, right? In terms of throughput and maybe the completion time of rebalance, things like that.
Yeah, and this information is per store level, and this monitor part might need add more. Yeah.
Yeah, I think we need a host level aggregate block transfer. So because right now we are actually looking at the NVMe write and read to basically infer from that. It's better if we can add a host level block transfer rewrite speed.
Do we have like a comparison on how long it would take to bootstrap a store through Kafka versus Blob transfer?
Yeah, we have a comparison for our one client, Flip, and their 10 store when they use Kafka ingestion, it take around 47 minutes, and when use Kafka, it only takes 6 minutes. And also we have a use case in our Venus server around 100 gigabyte store bootstrap through Bob transfer only take now because some code improvement it takes 3 minutes to bootstrap 100 gigabyte store. So now the further action is enable more store and make this feature stabilized.
So in terms of the enable this feature, receiver and sender, they, I guess my question is more about, are we gonna turn it on for all the Venice cluster, or will have dedicated cluster to do so, or what's the plan for that?
Our end goal is to enable all cluster, but of course at the beginning we only enable certain cluster.
I see.
And for our DaVinci client use case, they only select their big store. So for saving the time for small store, they don't care a lot. So for our server use case, we will enable cluster-wise the one by one. And for our DaVinci client use case, they are more like to enable this feature at per store level because some stores they are too small, so they don't care.
So do we have all the DaVinci client use cases in a dedicated cluster, or they actually spread out across all the clusters?
For DaVinci client use case, they're gonna be their all cluster.
I see. So that means if one use case want to onboard, we need to find a cluster to turn it on for them at the server side.
Yeah.
Okay, gotcha. Thanks.
We use this one for store migration in terms of like if we move the data around.
Oh, they are different use case because for store migration, the destination host is based on the cluster we pick. But in our current code logic, when we discover the destination host, they are within the same colo, same cluster, right? They are not host cluster. So they are different use cases, but that might benefit the store migration in the future if modified the first step.
Oh, quick question. So we're discovering peers from router D2, right? During the store migration, I think there's a way to find out the source D2.
For servers, should we discover in CV repository? For server block transfer, not for DaVinci.
In here, the use case is for Venus server. It's in router, and the router query the metadata repository. So for DaVinci, it's query from Venus push job. And for another use case, the store migration, they are different use case at all, even now.
Right. I guess I want to discuss like whether they're really a different use case. I guess the main difference is where we find the peers, right? Basically, we find the peers like within the same fabric and within the same clusters. Like, is it possible to discover from a different cluster?
Yeah, this is possible, but they must be in the same color. So in the peer discovery stage, we can use D2 to query the destination cluster host. Yeah.
No, I still don't
Right.
get it though. I have a question. For the server blob transfer metadata repository, I think we are using the CV repository, which should be looking at the same cluster, right?
Yeah,
No,
but
store-
Min is talking about the store migration.
Yeah, but then within the store migration, I think in the destination cluster, the peer should not be ready. They are all bootstrapping from nothing.
Right. We're discussing the, like, can the server in the destination cluster transfer data from the server in the source cluster? Let's say we migrate a store from Windows 0 to 1. Can server in Windows 1 cluster get the data from server in Windows 0?
Yeah, I think then we need code change.
Right, but at least it's feasible. It's just not supported yet.
Yeah.
Any other questions? So
Right. There's one detail I missed. Like when we take the snapshot, what's the order of the snapshot? Like metadata is the last one.
Oh, the snapshot part is also very interesting. Is we need to, even the transfer order is we send out the file first and then send the metadata. But when we do the preparation, is we take the metadata snapshot first. This is not like a snapshot. It's just store that value in the memory and then take the snapshot of the RuxDB. Why we have this order is if we take the snapshot of RuxDB first and then take the snapshot of the metadata, then snapshot, because this time order, the snapshot offset might be 2000, but the next second we take the snapshot of metadata, the offset record might be 1000 at 1001. So there might have slightly offset gap. So we have to take the metadata record first. At that time, the metadata record show is 1000, and then we take the RuxDB snapshot. At that time, the offset might be 1001. But if RuxDB data has more, it's okay, because later Kafka ingestion gonna fill it up. So this is how the snapshot order is taken.
Right. And you mentioned the metadata snapshot is in memory only, or we also have a file copy.
We have this is in memory only.
I see. Just curious, like why there's a difference like between metadata and user data partition.
Oh, this is the reason is the same that I talked about before, is we have to get a snapshot of the time before the RuxDB snapshot is taken. Because if we send out the file and refer the partition, the metadata partition, at that time the metadata partition's record may be higher than the real RuxDB value.
Right. But for the data partition, we do a copy to a snapshot directory, right? But for the metadata partition, we are not doing a copy. We
We
just
cannot
keep.
No, we're not.
because
why is that?
you are because the metadata partition contains a lot of other partitions, and potentially it can override. For example, you have
see.
the other partition, the metadata, and also coexist in the destination host. It will override your current one. It will mess up.
Yeah, makes sense. So basically, the destination host might have some checkpoint that doesn't belong to this transfer.
Yeah.
Yes.
Okay.
One question. Technically, we can transfer metadata and data files parallelly, right? On client side, if we don't like do renames, like directory renames until everything is received. It's just that we'll have to have like some sort of signal to tell, okay, I have transferred everything from server side.
So you mean that send out file and the metadata can parallel?
Yeah, everything can go.
This is available. And
So
oh,
right now,
yeah. Oh, go ahead.
yeah, so right now it seems like metadata file transfer is considered as like end of transfer signal. So it's implicit transfer complete signal. Transfer complete as in I have transferred all the snapshots if I get metadata file.
Oh no, this is they send out all the file and then send a metadata in JSON.
So there is complete signal, explicit complete signal.
No, it's not the complete signal. It will separate send a complete signal HTTP, and at that response, it only contain header and the content is empty.
Then we can transfer metadata files as well, right? Like in parallel, there doesn't need to be any dependency.
Yes, so the 1 and the 2 can parallel. This
Yeah.
is okay. Yeah, this part is okay. So now
You mentioned in the other section that the order should be
Yeah.
file and then metadata and then
Like data files and then metadata. If you hold back like renaming of directories on client side until complete is received, the order doesn't matter between files and metadata files for now.
Oh no, the complete flag is a separate response send it out, but this order must have order because in the client side it has a one central handler, and then when the file is sent in their handler there is a flag to indicate this is the file, and then client will transfer this file to the file handler to do the file writing everything, and then when the metadata is sent, the client side central handler will know that in their header there is a flag to show this is metadata and transfer to the metadata handler, and the metadata handler is do the sync offset part. So this must have the order, otherwise the handler received it just
So
parallelly send it out to the respective handler.
so what if you have two channels, one for file, the other one's for metadata?
This is because this is not a big deal. Is we want to manage the code better. We don't want one handler to handle both the file and the metadata. So have two handler to handle a different type. But we want to have separated. We want to have a specific order for this. We have talked about why it must have an order. They cannot parallelly send it out because if parallelly send it out, then they are still back to this wrong order, right?
and the thing is, I think you are invoking sync as part of metadata receive, right? Once
Yeah.
metadata file is received, you are syncing it immediately.
Yeah.
If you hold it back until complete signal is done, then there is no order. But I think this is maybe from performance standpoint. Yeah, from performance standpoint, maybe it's not a big deal.
Yeah, it's not a
Yeah.
big deal. I got what you mean. You mean that they can parallel send it out, but we only really sync it to the memory after the complete.
Yeah,
signal.
exactly.
Yeah.
Yeah. Like everything is in staging until complete signal is
Yeah,
received.
got
Yeah.
it. This is just a minor.
Yeah,
change, yeah.
I think maybe like like right now there's just one channel between client and server, right? Or like peer to peer. Or do we have like channel pools?
We don't.
Let's say I have 10 files, right? For one snapshot. Are we transferring those in parallel or are we transferring those one by one?
You mean is if there is 10 snapshot,
Or one snapshot but 10 different files
they are sequentially transferred.
right now?
Yeah.
Okay, so there is another like scope for.
We cannot do parallel transfer for file, which Ming have mentioned is because we have only one channel. This transfer is in one channel. So if we parallelly send out the file. And in single file deal, because we need to extract the file name and the write down file. If they are parallelly sent it out, even they are in different channel, then the file gonna mess up.
Not necessarily.
You mean per channel deal with one file?
Yeah, you can.
But then that is another question is about the scalability is normally one partition has 20 SST file, but one store might have, for example, 20 partition. Then the channel gonna be 20 times 20 is 400 channel is doing the file transfer parallel.
Like we'll have like let's say fixed thread, like we fixed channel pool, and that channel pool is multiplexed with partitions. Like whoever like channel 1, right, will take care of let's say partition 0, 0, 1 to 4, right? And whenever like someone else becomes free, like next channel becomes free, or it's done with let's say not partition file, right?
You know,
It takes up
dynamic to file. Yeah, I got it.
M channels and files.
Yeah, and this is bring up another question is currently even we do per partition use one channel, the transfer speed is already pretty low. So I have concern that if we have more channel to do the parallel transfer, won't it bring down the transfer time? Yeah.
So I think.
Go ahead.
Go ahead.
Sorry. So I think Shashank has a good point. The idea of channel pool might not be increasing the number of the channel or connection, but actually on the opposite, like can it help us like limit the number of connection? Let's say if we enable it in server and we have a rebalance storm, since we are opening connection at partition level, right? I'm not sure like what the impact will be. I guess we can start with monitoring first, like monitor the number of connection, things like that, and see how it goes.
Instead of like per partition, like there will be like fixed channel pool per like peer, right? Peer. Let's say there is
Right.
host A and B. They will have like static pool of let's say five channels or 5 connections, right? And then like whoever like all stores will basically use that same pool. Maybe it's currently like that.
But there is a question is that per partition, they might not use the same sender node. The sender node is randomly picked. So they might not.
But if they did, let's say, decide to go with same host, right?
Yeah.
There are 2 stores on that host, and if like both store wants to get data from same host, like you reuse like basic same infrastructure, right?
But in this case, then there is no much different than the current logic.
Like in
one
current
channel
logic, if you
sender
have
node.
one channel,
Yeah.
there is just one channel for the entire partition. But if you have like multiple connections, you get parallelism. No?
Yeah, and
If there are more stores, like it doesn't matter like how many stores you have. You will have like fixed set of connections.
Yeah.
And but if you have let's say just one partition, right?
Yeah.
In that case, you get maximum parallelism. If you have more, in that case also you're getting like parallelism, but without much downside actually. Yeah.
But that might have a question is whether the sender node can have that fast writing speed. If the sender node so what I want to mean is if the sender node writes that fast, the receiver node might have the ability to write it down as fast as the send out speed. I don't know if I make it clear.
Fine, right?
So if the receiver node, they are receiving all the file parallelly, then their speed will be very low. So at that time, all the byte is still waiting in the channel and waiting it to write it down.
I mean, it should be fine. We like we'll have to do experiments, of course. Yeah.
Yeah.
But again, yeah, I think we don't need to like spend too much time on it.
Is there any other questions? Or if you have further question, can comment on the PR. Yeah.
Good job.